over the next 2 lessons, I want to talk about the factorizing of cubic expressions and the solving of cubic equations. We won't get to solving cubic equations today. That will be our next lesson. And all of this is sort of geared towards helping you be able to answer those questions in calculus where we're working with the cubic function. All right, so we will talk about the cubic function in a lot more detail, but we obviously need all of this information in order to be able to answer these questions. All right, so what I want to go through this evening is the remainder theorem and the factor theorem. Strictly speaking, these are not exam type questions, but we need to understand remainder theorem and factor theorem in order to be able to factorize cubic expressions. So, you know, you can't sort of really do the one without discussing the other, okay? So this is what you need to know when it comes to remainder theorem. I'm simplifying things quite a lot, but these are the most important things that you need to know, all right? What we are doing is we are, so in the same way, like if you took the number 15 and you divided it by 2, all right, we would say that 2 goes into 15 7 times, and our remainder would end up being 1 in this case. All right, so it's the same idea. All right, so we can find a remainder when we divide a polynomial, so in other words, a cubic expression, for example, by a linear expression. All right, in the same way that we can find a remainder when we divide a number like 15 by 2. Okay, so when we calculate a remainder, what we do is we begin with our linear polynomial. And what we do is that we take this and we make it equal to 0, okay? Because we would treat x minus 2 like it was potentially a factor of f of x, even though it isn't, all right? And then what we would do is we would take the 2 over to the other side and we would say, okay, x would be equal to 2. We would find out what the remainder is when we then sub in 2 into our expression. Okay, so this would be 4 times 2 cubed minus 8 times 2 squared plus 2 plus 2. All right, and that number that we would get, that would be our remainder. So it's actually very, very easy. Okay, so it's just a case of making it equal to 0, taking that value of x, subbing it in, and the answer that you get is going to be your remainder. So I hope you guys have got your calculators, and we can work out what that remainder is in this case. Anyone got an answer for us that they want to share? What are you guys getting as an answer?
Let's see. Unati, you have your mic on?
That's it. Well done, Lebogang. I got the same answer as you. Good,
Nice,
guys. Okay, so the remainder is 4. Okay, so when f of x is divided by x minus 2, we get a remainder of 4. Very, very simple. That's all we need to know. Okay, here is one. Oh, sorry, maybe you want to take a screenshot. I'm going to move on and I'm going to give you guys an opportunity to try one. So screenshots, everybody. Okay, so here we go. All right, you guys try that one. I want you to determine the remainder when f of x equals 4x cubed minus 8x squared plus x plus 2 is divided by x plus 4. Okay, so you first need to calculate what x would be, and then you're going to go and sub it in. Una, try logging out and logging back in again. Just give me a second here, sorry. Dying of heat here.
Alessa, just try it again on your calculator. It could be that the way that you've put the numbers somewhere, just try it in to see if you get the same.
Yeah, and just make sure that you cubed. So We'll just go up here. Make sure that you did press the cubed button and the squared button. So sometimes that's what goes wrong. Okay, so Zonda got an interesting answer. Okay, I'm getting the same as what you guys are putting on the screen now. Okay, so minus 386, absolutely. Okay, so your remainder, when we sub in -4, we would get I'm getting the same as you, so negative 386. Okay, good, well done. Very, very easy thing to have to do. All right. Then what they can do is something like this. All right. They say to us that the remainder of when f of x equals minus 2x cubed plus ax squared minus 4x plus 3 is divided by x plus 3, the remainder is 15. Determine the value of a. Okay, so what they're expecting us to do now is to solve for a using remainder theorem. Okay, so we would set it out as follows. Okay, our remainder, when we sub in -3, is going to be equal to minus 2 times -3 cubed plus a times -3 squared minus 4 times -3 plus 3. And what do you think we do with the 15 matrix? Where do you think I should put the 15? Okay, in place of the, exactly. All right, so in place of your remainder. Okay, so 15 is going to go over here. Okay, and now it's our job to work out the value of A. All right, so you guys try and solve for A and tell me what you get. So you're going to do the rest of this and let's see if we get the same answer. Work out the value of A. Okay, so Salma says she gets 6. What do the rest of you get? Okay, so Leanne, you've got -0.5, and Tukozo's got -6, Tina's got -6, Balentle's got -6, Lebogang, you got 0. Okay, so you can't get 0. It's okay. I'm also getting -6 as my answer for this one matrix. Okay, so when we multiply this out, it would give us negative 27 times negative 2. So that would be 54 plus positive 9a plus 12 plus 3. So on the right-hand side, we'd have 15, take away 54, take away 12, take away 3 to give us 9a. So that gives us negative 54 on the right-hand side. And when we divide both sides by 9, we'd end up with a being equal to negative 6. Okay, good job, Matrix. Well done. Okay, any questions? Are we all cool with that one? All good, nice and easy. Okay, then they can also expect us to do it simultaneously. All right, so now we need to be very careful. G of x equals 16ax cubed minus 2bx plus 5, and when it is divided by x plus 1, the remainder is minus 9, while the remainder is 6 when it is divided by 2x minus 1. Determine the values of a and b. How do you think we're going to do this? If they want us to solve for two unknowns, what do we have to do? What do we have to do, Matrix? Exactly. All right, so we need to solve simultaneously. And if we solve simultaneously, it means that we need two equations. Okay, so we're going to need two equations. Good. Yes, absolutely. So let's figure out how we're going to make our two equations. All right, so we know that the remainder is 9 when we sub in negative 1. 16a times negative 1 cubed minus 2b times negative 1 plus 5. And what we can do is we can just tidy that up a little bit. So 9 would be equal to, and then in this case here, we would get negative 16a plus 2b plus 5. And then what I like to do is I like to take my number terms over to the other side. Okay, so in doing that, we would end up with 4. 9 minus 5 would give us 4 is equal to negative 16a plus 2b. And then I always leave my equation just like that. All right, we can decide what we're going to do once we've got our other equation in 2 seconds. Okay, what I'm going to do now is just scooch over a little bit, and there we go. Let's do the other equation. All right, so now we want to calculate our remainder. It's going to be 1 over 2. Sorry, so the remainder is 6 when 1 over 2 goes in. So that gives us 16a times 1 over 2 cubed minus 2b times 1 over 2 plus 5. And again, we just need to tidy things up. So we've got 6 equals. Okay, so now the coefficient of A is going to be 2, if I'm not mistaken. And then here, that's going to be minus B. And then we're going to have plus 5. And again, we want to take that plus 5 over to the other side. Okay, so that means we're going to end up with 1 equals 2a minus b, and there is equation number 2. Okay, so I see, did I make a mistake? I see there are some people with hands ups. Nazi?
Ma'am,
Yes?
where did you get negative 1? Did you take out x plus 1 out of the brackets?
Sorry, just ask me again. Where did I get the negative 1 from?
Yes, ma'am.
Okay, so it's this bracket over here. When you want to work out what you're going to sub in, you're going to take that, you're going to make it equal to 0. So you're going to sub in
0.
-1. Yeah. So it's the same thing with the other one. If you've got 2x
Okay.
minus 1, then x would be equal to 1/2. That's why I've subbed that in here. Okay.
Okay. Thank you, ma'am.
All right. Okay. Now that we have got to this point over here, all right, we want to solve these two equations simultaneously, all right? So it's up to you whether you want to solve by substitution or whether you want to solve by elimination, right? Probably substitution is the easiest thing for you, right? So look for an equation. You can, Leanne, that's exactly what we're going to do now, is we're going to make B the subject of the formula. So I'm going to take B over to this side, and I'm going to take the 1 over to the other side. Lovely. Okay, great suggestion, Leanne. And now I'm going to take that and I'm going to sub it into the other equation. Okay, so that means we've got 4 equals -16a plus 2 times the value of b. B is 2a minus 1, and then we will be able to solve for a. Lebogang, the -1 comes from here. The 1/2 comes from here. Okay. So you get 4 from saying 9 minus 5 when you take the 5 over to the other side. Okay, so 4 is equal to -16a plus 4a minus 2. And if I take this 2 over to the other side, it would be 4 plus 2. And on this side, I've got -16a plus 4a. That would give me -12a. So if 6 is equal to -12a, then I now need to divide both sides by -12. Okay, and that means that a would be equal to -1/2. Okay, good. Well done. There you go. All right, lovely. And then we can use our other equation to work out the value of b. Okay, so b would be equal to 2 times the value of a, which is -1/2. And then we've got to take away 1. So this would give us -1 minus 1. So therefore b would be equal to -2. Okay. Palesa, please explain at the -12. You mean over here, Palesa? So what I've done is I've taken that 2 over to the other side. Okay, so I've added 2 to both hand sides of my equation. All right, so I've got 4 plus 2 on the left, which gives me 6, and -16a plus 4a gives me -12a on the right. That's it. Thanks, Yolanda. Perfect. Okay, so can you just explain to me, hold on a second. Nonjabulo, what is it that you're not understanding?
Nazi, is that hand up for question?
I think it was from a while ago.
Oh,
I
and
think.
Nonjabulo, it's always nice to tell us like exactly where do you get stuck.
Yeah, where are you stuck,
Yeah.
Nonjabulo? Can you explain that to us? You're welcome to unmute and speak.
So after you got the values of half and of half and of half and -1, do we
Mm-hmm.
take do we sub answers to the equation and do it one by one? Like,
Exact. Exactly. So what I've done is I've got -9. Oh, hang on a second. I've just seen I've made a mistake here. Sorry. That's supposed to be -9. Anyway, it doesn't matter. Let's just leave it as +9. It doesn't matter. Let's not go back and change it now. We'll just make that 9. Okay. So what the question was saying is that when we sub in -1, our remainder is 9. Okay. So we're subbing -1 into our equation, and then we're making that equal to 9 because that is our remainder. All right. Same story on the other side. They've told us our remainder is 6. So we've subbed our 6 in over here when it is divided by 2x minus 1. That's why I've subbed a half in over there. Okay, and then I've made 2 equations in terms of A and B. All right. And then solved them simultaneously. Rearranged to make B the subject of the formula, and then I've gone and subbed back into the first equation. Okay.
Okay.
All right. Everybody happy with that? Any questions? All right, so being able to solve simultaneously is a very important skill because we're going to be using it all over the place. So we use it in sequences and series, we use it in calculus, we use it in analytical geometry. We're going to be expected to solve simultaneously in lots of different places. So it's very important that we are able to do that. All right, if that's okay, I'm going to move on and I'm going to talk about factor theorem now. Okay. So when a number is a factor of another number, what is the remainder? When a number is a factor of another number and we divide that number into the other number, what is our remainder going to be? Exactly. Okay, so our remainder is now equal to 0. Okay, so if x plus 2 is a factor of f of x, it means that our remainder is going to be equal to 0. Okay, very important point. All right, good job, everybody. So when they ask us to show that x plus 2 is a factor of this expression, this is what they want from us, okay? Our remainder, when we sub in -2, so we get -2, and we cube it, minus 3 times -2 plus 2. We're expecting to get 0 as an answer. Okay, so that will give us -8 plus 6 plus 2. We end up with 0. Okay, and then we must say, therefore, x plus 2 is a factor of f of x. All right, so we're expecting to get 0 as an answer if a linear polynomial is a factor of another polynomial. All right, so screenshots. And then I'm going to show you how we use this. Everybody ready? Okay. Next one. So if x plus 2 is a factor of 3x cubed plus px squared minus 2x plus 8, we now want to determine the value of p. Lusanda, what's up?
Hi, ma'am.
Hi, are you okay?
I'm good. How are you, ma'am?
I'm fine, thank you. Are you stuck on
Ma'am,
something?
no, can you just call up a bit? I want to take a screenshot.
Oh, okay. There you go. Sorry, did I move off a little bit quickly?
Yeah, thank you.
Sorry, beg your pardon. There you go. Sorted.
Yes, thank you, ma'am.
All right, no problem. Okay, so in this case over here, again, we would set it out in the same way. our remainder is going to be equal to 0 because it is a factor. Okay, when we go ahead and we sub in -2. Okay, so we're going to have 3 times -2 cubed plus p times -2 squared minus 2 times -2 plus 8. And now we can solve for p. All right, so you guys go ahead and do that. Let's see what you get. Excuse me. There we go. Good job. Okay, correct. That is the right answer. Okay, so you should be getting 3. Well done, everybody. Okay, so just for those of us that perhaps weren't sure, we would end up with that. So if I bring the 4p over to the other side, then on this side I would have -24 plus 4 plus 8. So if -4p is equal to -12, it means that p is 3, just as you guys had indicated. Well done. Good stuff. Okay, so it's very easy. All right, so if they tell you that the remainder is -15, then you're going to make your equation equal to -15. If they tell you that your linear polynomial is a factor, then you're going to make your remainder equal to 0 in order to solve for an unknown. Okay, so now again, here's more practice. Sorry, Lucinda, did you want to take another screenshot? Or did
No,
you want to
ma'am.
ask a question?
I want to ask a question.
Sure.
Ma'am, I wanted to know, is it fine if you put the -12 to the other side instead of the -4p?
Absolutely, absolutely. So if you collected your number terms on the left, that's not a problem at all.
Okay, thank you.
Okay, pleasure. Okay, and then you can see here, this is a mixture of the two. All right, so it says given the expression 2x cubed plus ax squared plus b is divisible by x plus 1, and that there is a remainder of 16 when it is divided by x minus 3, find the values of a and b. So here in this particular question, we are combining what we would do with factor theorem with what we would do with remainder theorem. Okay, so I would like you guys to assist in making the equations here. Okay, it's boring listening to my own voice. It's much nicer listening to yours. So is there anybody who'd like to volunteer to make one of the first equations? Doesn't matter which one it is, but one of the two equations that I need here. Do I have a volunteer? Don't worry, Yolanda and I will assist you if you need help. Anybody want to tell me what they think we should write? Yes.
We are
Who might?
here.
Yes, we are here.
Come on, guys. I have a tendency of just like picking up on somebody. So it will be nice for someone to just tell us. If not, I'm okay. I know I'm putting you on the stage, girl, but do you want to help us out? We will definitely help you. Yes, Leanne, you can try. Leanne, I hope that's
Go
the
for it.
correction.
Yes.
Go
Go
for
for it,
please.
Leanne.
So, ma'am, since we
Mm.
have the equation 2x cubed plus ax squared plus b is
Mhm.
divided by x plus 1 and then
Mhm.
remainder of 16. So the first thing we'll do is f of x is into negative 1, which is equals to 2x into negative 1 cubed plus a into negative 1 squared plus b.
Mhm. And what does that need
And
to be
then we'll
equal to?
say equal to 16, ma'am.
Careful. Okay, now you've done a great job. You've done a great job. All right. Right. What that says here is it says given that the expression is divisible by x plus 1. So that is separate from the and that there would be a remainder of 16 when it is divided by x minus 3. So if it is divisible by x plus 1, it means that x plus 1 is a factor.
Okay, ma'am.
Does that make sense to you?
Yes.
So x plus 1 is a factor. So what should we make all of this beautiful stuff that you've given me? What should we make it equal to?
20.
Beautiful. Lovely. Well done. Okay, so that would give us negative 2 plus a plus b. So that means the 2 would be equal to a plus b. Fantastic.
Done, Leanne.
Okay, Leanne, that's stunning. Well done. Excellent job. Okay, now we need to make a second equation. Anybody else want to offer to make the second equation for us, please? Anyone want to try making the second equation?
Yes, Sandra.
Lucinda.
Thank you.
Cool. Go for it, Lucinda.
Ma'am,
Mm-hmm.
I think you're gonna do f is 3
Mm-hmm.
is equals to 2 times 3 cubed
Good.
plus a
Mm-hmm.
times 3
Lovely.
plus b.
Mm-hmm. And then what are we going to
And
make f of 3 equal to?
it's gonna be equal to 16.
Excellent. Good job. Well done, Lucinda. That's fantastic. Okay, very, very nice. So that's going to give us 54 plus 9a plus b. And if we collect things together and take that 54 over to the other side, we would end up with negative 38 on the left, 9a plus b on the right-hand side. So this, courtesy of Leanne, is equation number 1. And this, courtesy of Lucinda, is equation number 2. Good job. Okay, Leanne, can we change? Yes, absolutely. Okay, so either Leanne, either will work for you. Okay, so now what I'm going to do is I'm going to let you guys solve simultaneously from here, okay, and work out the values of A and B. All right, and then we can share our answers. When you're done, you can say done in the chat, and then we can talk about what you did. Okay, so go ahead and solve for A and B now, and let's see what you get. Cool. A few of us that got done. Yolanda.
Yes, Charlie.
Sorry, sorry. I've just realized I'm going to have my usual Thursday evening load shedding at 6.
No worries, because
Okay, I'm just, you're at Spur.
I think everything should be fine. But if they have load
Okay,
shedding, it takes the generator to be in. So I think maybe what
okay,
I'm gonna do is just I'm gonna leave the class a little bit early so that I can join the 6 o'clock class.
that's fine. I was just letting you know as well, so that's perfect.
Okay.
All right, so
Thank you.
thank you. Okay, so I see some answers coming through. Leanne's got 5 and 7, or is that -5 and 7? Onwaba's got -5 and 7 as well. Okay, Caleb, you got 4 and 6. Alwetu got -5 and 7. Amahle got -5 and 7. There we go. All right, so I got the same. I also got -5 for A, and I got 7 for B. Caleb, maybe there was just a little mistake that you made, not the end of the world. All right, so one thing that you could do if you wanted, Caleb, right, is let's say you decide you want to make, in fact, Caleb, you tell me, which one did you make the subject to the formula? Are you okay to talk,
Ma'am,
Caleb?
I made B.
B in which equation, number 1 or number 2?
I made B equal to A plus 2, and then I put it into equation 2.
Oh, okay. So if you're making B the subject of the formula and A is going over to the other side, it would have to be 2 minus A. Is that maybe your mistake? All right, and then you could go ahead and go and sub that in. So you'd have -38 equals 9A plus the value of B, which would be 2 minus A, like so. Not that the brackets are going to make any difference at this particular point. So we're going to take the 2 over, excuse me. So we're going to take 2 away, and then over here we'd end up with 8A, dividing both sides by 8, and that's where the -5 comes from. Subbing back in here for B, we've got 2 minus -5 is equal to B, and that's why B would be equal to 7. Okay. Onwaba? You're welcome to
Hi, ma'am.
Hi, Onwaba.
My question is, I got the answers right, but
Mm-hmm.
in the exam, am I going to be wrong if I minus the other equation from the other instead of substituting?
No, absolutely. That's exactly how I do it. So
Okay.
that's exactly how I like to do it as well. I just didn't want to mention that because I don't want to create, there are some people that just don't like to use that method. I prefer that one myself. I always do it like that. So yeah, do it that way. That's how I do it too. So no problem.
Thank you.
Cool. Thanks, Onwaba. All right. Absolutely. I love that. Mamelo, very nice. You made B the subject of both of them and then equated them. Absolutely. Another fantastic method. Nothing wrong with that either. You would have got the same answer. All right, lovely. It's really nice to be able to talk about the different ways that we can answer a question. Okay, so that's a lovely suggestion, Mamelo. I'm so glad you told us about doing that as well. 100%, nothing wrong with that either. Okay, so the truth is solving simultaneously, there's many different ways in which we're able to do it. And provided we do something that's mathematically sound, it's absolutely fine. Okay, very nice suggestions from both of you. Thank you so much. Cool beans. All right, so now let's jump into what it is that I actually wanted to show you this evening. So we're going to use factor theorem. Okay, and we're going to need to use factor theorem in this case because we're going to look at this one over here. Ignore that one. That's for you guys to try. We're going to use factor theorem over here where they've asked us to factorize f of x equals x cubed minus 4x squared plus x plus 6 as far as possible. Okay, now we need factor theorem because we have not been given a linear polynomial. Right now, there is no other way for us to be able to do this other than a little bit of trial and error to start off with. Okay, before I carry on Waba, you got your hand up? No, am I fair?
Sorry.
It's okay. It's fine, no problem.
Ma'am, is the type of questions that we were doing just now, are those the type of questions that are going to come out in the exam?
Amahle, that's a very good question. Factor theorem and remainder theorem are not exam questions, but they could
Okay.
come out in control tests. Okay, but you need to understand remainder theorem and factor theorem in order to be able to factorize cubic expressions. That's why I
Okay.
wanted to show you that. Okay,
Oh,
but what we're going to do now, this is exam material.
oh, okay.
Okay. All right, cool. No problem.
Thank
Okay,
you
so
so
now
much.
it's a pleasure. It's a pleasure. Okay, so now you never ever hear teachers say this when we ask you to solve equations, but anyway, here we go. Now what you need to do is you need to pick up your calculator. We need to find a linear factor of f of x, bearing in mind, okay, that it also has to be a factor of 6. So we're going to try 1, we're going to try -1, we're going to try 2, we're going to try -2, we're going to try 3, we're going to try -3, okay? So we're using factor theorem. All right, we want to get 0 as an answer. So what happens when we sub in 1? All right, so in other words, we're testing now, okay? When we sub in 1, do we get 0 as an answer? Okay, so this gives us 1 minus 4 plus 1 plus 6. Do we get 0 as an answer? Okay. No, we don't. Okay, we don't get 0 as an answer. So that means that didn't work. So now let's try -1. Oopsie, that must be -1. Okay, so that would give us -1. You can do this on the calculator. Do we get 0 as an answer now? Yes, we do. Okay, we end up with 0 as an answer. Okay, so if f of -1 gives us 0 as an answer, what does that mean? It means that x plus 1 is a factor of f of x. Okay, so we're going to use that. All right, let's grab this and go down a little bit. Okay, so now we want to factorize. So we've got f of x equals x cubed minus 4x squared plus x plus 6. And we know that one of the factors is x plus 1. All right. In order to get a cubic expression, we're multiplying a binomial with a trinomial. So I'm going to call my trinomial ax squared plus bx plus c. Okay. Exactly. And now I'm going to use a method called inspection. Now, your teachers at school may have showed you long division, which is dreadful, all right? And they may have showed you synthetic division, where you end up drawing a line like this, and then you've got like a 1 and a -4 and a whatever. So both of those methods are acceptable, but there are certain situations where neither of them work. That's why we like to do it by inspection. Okay, so that's why I'm showing you this method, because it always works in all situations. Okay, when you are multiplying your binomial with a trinomial, when I multiply your x with the ax squared over here, that's how I get my ax cubed term. So what I do is this, is I say x times ax squared is ax cubed. And then I go and I look at my ax cubed term over here, and I can see that it's equal to 1x cubed. So because my coefficients are the same, I can now deduce that a must be equal to 1. All right? The only way that you get the last term is by multiplying 1 with c. So I'm going to multiply 1 with c together, and that's going to give me the last term over here, which is 6. So that means that c has to be equal to 6. Now, this is the part that's just a little bit more tricky. In order to work out what the value of b is, right, I'm going to use this term over here, the -4x squared term. But there are 2 places in my multiplication where I'm going to get an x squared term. I'm going to get an x squared term when I multiply x with bx. That's going to give me bx squared. And I'm also going to get an x squared term when I multiply 1 with ax squared. Now, I already know that a is equal to 1. So I've got 1 times 1x squared, which is 1x squared. And again, I can see that it's equal to -4x squared in my equation. So I'm going to make it equal to -4x squared. Then what I can do is I can drop my variables. So essentially what I'm doing is I'm saying that b plus 1 is equal to -4. Take my 1 over to the other side, and that means that b will be equal to -4 minus 1, which leaves me with -5. There we go, Leanne. Well done. Okay, so in other words, it's now going to factorize into x plus 1 times a is equal to 1, so that's 1x squared, b is equal to -5x, and c we said was equal to 6. And now all we need to do is factorize our trinomial a little bit further. Okay, so there's a negative over here and a plus there, so both brackets have to have minus in them, and it would end up being that. And it's fully factorized. Okay. Tamia, I don't know if I pronounced that correctly. Do you have a question?
Hello, ma'am. You lost me from
Hello.
the beginning.
I know matrics often struggle with this one. Okay, so I'll show you this again. All right, how to do it. Right, what we want to do is we're trying to factorize our expression as far as possible. Okay, so from the very beginning. All right, so I'm going to rub it out. Actually, you know what? I won't rub it out because that's just going to waste time. Let's go down here. All right, so were you okay with how we found a linear factor? All right, remember up here, when we subbed in -1, we got 0. So that means that x plus 1 is a factor. So in other words, if we are factorizing f of x, we know that x plus 1 is a factor. When you multiply a binomial with a trinomial, that's how you get a cubic expression. All right. So in other words, if I take x plus 2 and I multiply it with x squared plus 3x plus 4, I'm just making up numbers. All right. When I multiply x with x squared, that's where x cubed comes from. X with 3x, I get 3x squared. X with 4, I get 4x. 2 with x squared, I get 2x squared. 2 with 3x, I get 6x. And 2 with 4, I get 8. Okay, so that's what you're trying to do. You're trying to work out what the coefficients of the x squared term, the x term, and the constant term in your trinomial are. All right, so we have got ax squared plus bx plus c. We need to work out the values of a, b, and c. So we're using inspection. We're looking at it to get our answer. So the only place that we get an x cubed term is by multiplying firsts with firsts. So this guy and that guy. So when I multiply x with ax squared, I get ax cubed. When I go back to my equation, I can see that it's 1x cubed. That means that a has to be equal to 1. Okay, then last and last. So 1 and c, the only way I get the constant is by multiplying last with last. And I can see that my constant is 6. So c has to be equal to 6. Now, did you see in this particular multiplying out that I did over here, I've got 2x squared terms. There's an x squared term and there's an x squared term. I got the plus 3x squared by multiplying x with 3x. So I'm going to do the same thing here. I'm going to multiply x with bx, and I'm going to end up with bx squared. But I also got an x squared term when I multiplied 2 with x squared to get 2x squared. So I've got to do the same thing here. I'm going to multiply those two together. I already know that a is 1. So when I say 1 times 1x squared, I end up with 1x squared. And then by inspection, I can see that it's equal to negative 4x squared. Okay, and now it's like you can work with the coefficients because the variables are all the same. So you're going to say b plus 1 is negative 4. So b would be equal to negative 5. All right, so then you can go ahead and go and sub that in. We know that a is 1. We know that b is negative 5. We know that c is equal to 6. All right, and now we can go ahead and factorize our trinomial that's left over. Okay, that's the idea. All right, questions? We are going to do this in more detail again next lesson. Okay, so when I see you again on Tuesday, I'm going to go through this concept again because we need this concept to be able to do those questions. Yes, Lucinda.
I just wanted to know, you see the working out that you're doing on the sides, like ax
Yes.
cubed equal to, are we allowed to do it in the answer sheet, or are we supposed to do it on the script sheet and transfer it back?
No, you can do it just as I've set it out like this over here. You can do that there and then you've shown your working. That's no problem at all.
Okay, ma'am.
Okay. All right, so don't stress. I will go through this again when we do our next lesson. I just wanted to show you this evening just to give you something to think about. Okay, Lebogang, do you want to ask a question?
Oh, yes, ma'am. Can I just clarify something? I just want to confirm something, ma'am. So, ma'am, when it comes to the middle term,
Yes.
so, ma'am, could you say that, you see how we got negative 5x? So is it basically the x multiplied by so ma'am, sorry. So basically, if you say 1x times ax squared, you'll get
Yes.
the answer. And then do you say whatever added to ax squared will give you the middle term.
Correct, correct. So in other words, to get that x squared term, it comes from the sum of two other terms. So if you look at our example at the top here, if I wanted to simplify my x squared terms over here, I'd say 3x squared plus 2x squared would give me 5x squared. All right, so I'm working backwards from this to these two. All right, in order to be able to work out what b is equal to. So when you multiply x with bx, you get your bx squared term. When you multiply 1 with ax squared, you get your 1x squared term. And then you're going to go back and make it equal to whatever they gave you in the equation. Okay.